This data is on the first page. Let us go to the title of the experiment, the uniformly accelerated motion. Theory of this experiment already we discussed in the chapter number 2. Now let me explain this again. Then we will get into the actual experiment. Uniformly accelerated motion. Accelerated, you know the meaning of that. The acceleration is positive. If acceleration is positive means the speed of the object increases uniformly, gradually, right? The speed of the object, the speed of the object in the motion increases. How it is increases? Uniformly. The speed increases uniformly. That means the acceleration is constant throughout the motion. Uniformly accelerated motion means acceleration is same or constant, is not allowed to change during the entire motion. And this is the meaning of uniformly accelerated motion. We are going to do an experiment on uniformly accelerated motion. Before getting into the experiment, can I ask one question? Can you give the example for uniformly accelerated motion, Shabab? Anyone? The example for uniformly accelerated motion. Shabab? Online?
Yes, doctor.
Uniformly accelerated motion. Any example? No example? Can I take the motion of your car from home to the college as the example for uniformly accelerated motion? Say yes or no. Can I take the example of motion of your car from your home to the college? Can I
Yes.
take it as the example for uniformly accelerated motion? Yes or no?
I think no,
Yes.
doctor.
Yes?
No,
No? One yes,
because you
one
have.
no?
Mhm.
Yes?
No, doctor,
Continue.
because sometimes you will have to stop uh, at somewhere
Yes.
or زي كذا,
Yes, yes, you
like
are
this.
very right. You are very much right.
Not a formal or
Yes,
uniformal
yes,
other
yes,
acceleration.
you are right.
Mhm.
The acceleration of the car is not uniform from your starting point to the ending point. The acceleration keeps changes. Sometimes positive, sometimes negative, sometimes zero. The value of acceleration keeps changes throughout the motion. For the motion of the car, I cannot take it as an example for uniformly accelerated motion. Then, what is the real example for uniformly accelerated motion? You can give the motion of any object due to gravitational force is a uniformly accelerated motion. If you drop an object, if you drop object from certain height, dropping, you are not giving any force to the object, just drop it. Now
Free
the
falling.
object is moving due to gravity, right?
Free falling.
Is moving due to gravity. Initially, the speed was zero. As time increases, the speed keeps increasing. The maximum speed will be at the point just before touching the ground. Now, if you see the object, the motion of the object is moving due to gravity only. What is acceleration acting on the body now? It is acceleration due to gravity. What is the value of g on the earth's surface?
Minus 9.8.
No,
9.8. The magnitude
9.8.
is 9.8. Minus
Positive.
represent it is acting down.
Oh, I'm sorry.
The gravity value is constant. If the object is moving due to only gravitational force, the acceleration due to gravity is a constant. The acceleration due to gravity is constant. Now you can take any motion, any motion of any object due to gravitational force as an example for uniformly accelerated motion, because the acceleration is uniform throughout the motion. Acceleration is 9.8 throughout the motion. Okay. Now you understand what is uniformly accelerated motion. Let us come to the title and then we'll start our actual experiment. The objective. The objective of today's experiment: to test the relationship between the distance and time for an object moving under gravity. We are going to check how the distance changes with the time taken to travel the distance for an object moving under gravity. If the object is moving under gravity and that motion is uniformly accelerated motion. For uniformly accelerated motion, I'm going to check the relations between the distance and time taken to travel. We are going to draw the graph between the distance and time taken to travel. From the graph, I can understand the relations between the distance traveled and time. By using this relation, and then to determine the value of acceleration due to gravity. And using this relation, I want to determine the value of acceleration due to gravity. I want to calculate the value of g. Can you compare this experiment and experiment number 1? The experiment number 1, freely falling body. We also calculated g by using freely falling body. Freely falling body is also uniformly accelerated motion. Now also we are going to calculate the acceleration due to gravity by using uniformly accelerated motion. Now the motion of the object is different from the previous one. The first experiment, the object was traveling in a straight line. Now the object is moving in a slanting plane, right? Now we are going to check the relations between the distance traveled and time taken to travel the distance and use these relations to calculate the acceleration due to gravity. This is our objective. Now let us go to the actual experiment. Now in this experiment, there are two parts in this experiment. The first part, we are going to calculate, what is this? Okay, it's not coming. Okay. There is a problem here. Not this. Where is that? Yes.
So, doctor, the acceleration will that increases by the time?
No.
No.
If acceleration increases with the time, that motion is not uniformly accelerated motion.
Mm-hmm.
The acceleration should be constant. It
Constant,
should not
same
change.
value.
Yes, it should not change with the time. It should be the same,
Okay.
right? Oh, it is not writing good. Okay. Uniformly accelerated motion. First to calculate theta. Okay. And here we have a flat surface, a glider. Sorry, the slanting surface is like this. It makes an angle theta. You have a glider. The glider is moving over the slope. First, let me calculate theta and then go to the other actual experiment. To find theta, this theta, you select any point at the higher level and find the height of this point from the floor. This is your h2. And find one more point on the slanting surface. Find the height. It is h1, right? The distance between the first point and last point is your L, right? Now draw a horizontal line. This is also E equal to theta. This theta should be the same. Now this height is h1. The entire height is h2. What about this height? This height is equal to h2 minus h1. Is it right? h2 minus h1. The total height is h1. This height is h2. This is h2 minus h1. Now I am going to consider the triangle, only this triangle. This is theta. The hypotenuse is L. The opposite side is H2 minus H1. I don't know the adjacent side. Let us not worry about that. From this triangle, can I find sine theta? Sine theta is equal to opposite side by hypotenuse. What is opposite side? H2 minus H1 by L. H2 is the height of the highest point, the first point. The H1 is the height of the second point. And L is the distance between first point and second point on the slanting surface. From this, I can calculate theta. Theta is equal to sine inverse. Take the sine to the other side. H2 minus H1 by L. This is your theta. I'm going to use this formula to calculate the time taken to the angle of inclination. This is part number 1. Now come to the part number 2. The relation between distance and time. Distance traveled and time. Here I'm taking same object. Is that is underlined? Right. This is theta, right? This is theta. Now I take an object. The object is traveling on the slanting surface. The glider, it's called as a glider. It has the mass m. You know, the weight of the object is acting down. Let us take this is an x-axis. The opposite direction is your y-axis. The perpendicular direction, sorry. The perpendicular direction is your y-axis. This is your y-axis. Now, this is the theta. The angle of inclination, this is also equal to theta. Can I resolve the weight into two components? mg cosine theta and mg sine theta is acting in this direction. When you keep a glider on the surface, the glider will not move now. So the gravity pulls the object down, the gravity is pulling the object, even then the glider is not moving. Why? Because there is a friction between the glider and the surface. And the friction does not allow the glider to move, though it is pulled by the gravitational force. Then what you are going to do now? I want to reduce the friction. How can I reduce the friction? There is a small hole on the surface and blow the compressed air through the hole. Now the glider is slightly lifted above the gliding the surface. When the contact is cancelled between the contact is removed between the surface and the glider, and the frictional force is reduced or minimized. Now, when the absence of frictional force, the glider moves smoothly due to the gravitational pull. This is the concept. Now here the mg resolving into two components. The Fn is acting in the upward direction. There is no friction. The friction, if it is existing, it should be acting up. But here there is no friction. Now let me write the second law of motion. Fx is equal to ma. Why? The object is moving in the downward direction, and in the direction the object has the acceleration. Sigma Fy is equal to 0. Why? The object is not moving in the y direction. Let me expand this. How many forces are acting in the x direction? mg sine theta minus. Why minus? The mg sine theta is acting in negative direction. Is equal to m into minus a. Why minus a? The acceleration is acting in the negative direction. This is the positive x direction. This is the negative x direction. Now let me write f sigma fy. How many forces acting in the y direction? 2. Fn minus mg cos theta equal to 0. Now take the first equation. This minus get cancelled. This m get cancelled. Now a equal to g sine theta. Right? I got the relation. A is the acceleration of the moving glider. Now let me explain one more thing. There is a distance traveled and time. This is the actual experiment. This is theta, right? The object starts its motion at this point. Where the object starts its motion is called as x1, initial position. This is the photo gate 1. The photo gate 1 is the location of x1. At that point, the glider starts its motion. We assume v0 equal to 0. That means initial velocity of the glider at the starting point is equal to 0. We have another gate, that is gate number 2. This location of gate number 2 is your x2, the final position. Now can I find the distance traveled between this and this? x2 minus x1 is the distance traveled by the object. I can also calculate the time taken to travel the distance by using the timer. Now can I use the equations of motion? S is equal to v0t plus half at square. Now what is the distance traveled for the problem? x2 minus x1. x2 minus x1. What is v0 according to this problem? 0. The t is the time taken, 0t, plus half a equal to the sometime back we got g sine theta, a equal to g sine theta t square. Now simplify this. x2 minus x1 is equal to half g sine theta into t square. I want to find the acceleration due to gravity from this. G equal to 2 into x2 minus x1 whole divided by sine theta into t square. And this is the formula I'm going to use to calculate the acceleration due to gravity in today's experiment. Let us divide this into 2. Sine theta, this is one group, and this group I'm going to keep as a constant, x2 minus x1 divided by t square. This is group number 2. This is a variable group. I'm going to use this formula to calculate the acceleration due to gravity. Any doubts about?
Doctor, can I use the first g equals to 2 times x2 minus x0 x1?
Yes.
Okay.
I'm going to use this formula to calculate g.
Okay. Doctor.
Yes.
We will find only the gravitational acceleration.
Yes. Okay. Now this experiment has two parts. I told you. I explained the theory, and there is nothing here. And this is the first part. I'm going to find h1, h2, and L. How to find h1, h2? The height of the highest point is h2. The height of the lowest point is h1. The distance between these two is equal to L. Clear? By using this formula, I'm going to calculate your theta. Theta is equal to sine inverse of h2 minus h1 by L. You are fixing L for this problem. You are fixing L. Find your h1, h2 for the first position and shift the L and find new h1, new h2 and shift again new h and h2. By using this formula, you can calculate the theta. Theta equal to sine inverse of h2 minus h1 divided by L. I think same value you can enter here. And you are repeating the experiment for 3 times, then you will get 3 values of theta, right? And in order to get the error minimal error, and we are going to take the average of the 3 data. How to get the average? Add the 3 theta values and divide by 3, you will get the average angle of inclination. Any doubt, Shabab? This is the part number 1.
Doctor, how we can calculate the H1 and H2?
Using the tape measure, I will show you the video.
Mm-hmm.
Okay?
Theta طيب دكتور.
Theta, see the formula. I given the formula.
Yes,
Use
I
the
know.
formula to find theta.
The same value, the doctor, in the third column. I will
Yes.
put it in the theta.
Yes. Now come to the
Doctor,
yes.
excuse me, average is and put the theta and divide the 3, right?
Yes.
Okay, thank you, Doctor.
Now you are going to fix x1. How the position of glider 1 is your x1. At what point the glider starts the motion? It is x1. I will teach you how to. I will show you how to measure x1 from the video. Now the x2 is fixed. What is x2? X2 is the position of the glider number 2 or gate number 2. Sorry, not glider, gate number 2. And your x2 is the position of gate number 2. You can change the gate number 2 position according to the values given. First keep at 60 centimeter and 70 centimeter, 80 centimeter, and so on. And x2 minus x1, this is x2, this is x1. Can I get this answer? Again, this is x2, x1. X1 is the same for entire experiment, but x2 is changing. You can get the time taken to travel the distance and keep your x1 here, x2 as 60 centimeter, and find the time taken to travel the distance by using timer. Can you square this? And repeat this experiment for various values of x2. x1 should be constant. I'm not changing the x1, I'm changing only x2. And can you find the time taken to travel the distance? And square it. And repeat this experiment by changing x2 from 60 centimeter to 150 centimeter. Now I will share you the data. I will explain how to measure your x1, x2, h1, h2, everything here. After the video, I will share the data by using copy the data on your paper. By using the data, you can draw the graph.
Doctor, you will give us the time, right?
Yes.
Doctor, how we can get the average, theta average again, please?
Add the 3 numbers divided by 3.
By 3, okay.
Yes, you can watch the video now.
Doctor, we can't hear the voice.
Yes, doctor, it's very low.
Now?
Yes, it's
Also,
good.
Uniformly accelerated motion. The objective of today's experiment is to test the relationship between the distance and time for an object moving under gravity, and then to determine the value of acceleration due to gravity. This is our objective. The schematic diagram of the equipment we are going to use today. Let me show you the equipments and introduce different part of the equipment. This is the air truck and the glider, and the glider can glide due to the gravitational force only. Now the glider cannot move easily because there is a friction between the glider and the surface. I want to cancel the friction. How can I cancel the friction? I have the air compressor. The air compressor compresses the air and flowing through the small hole. Now the friction is reduced. Now say this. The glider is moving freely due to gravity. an object is moving freely due to gravity. And that's the glider. And this is the gate number 1. This is gate number 2. And this is the timer. This is the timer. I'm going to measure the time taken to travel the distance x2 minus x1 by using this timer. I will tell you the setup of the timer later. Now coming to this, first I'm going to do the first part. There are two parts for this experiment to determine the theta, the angle of inclination I'm going to measure. How to measure this? Fix the length L, measure h1, h2, and by using this formula and find the theta. The theta is equal to the sine inverse of, yes, you can use this formula, sine inverse of h2 minus h1 by L. And this is your theta. I'm going to measure this theta now. See, this is your L, this is h1, this is h2. And this theta I'm going to measure. The theta equal to sine inverse of h2 minus h1 divided by L. I'm going to fix the L. Let us fix the L as 50 centimeters. Now I fix the L. I'm going to measure h1 and h2 by using tape measure. Now take this. You can fix.
Doctor, he will give me the L.
You can fix some value. I'm going
Yes.
to measure the height of this from the table. Take the tape measure and fix the value 10 and measure the height from the table. It is 29.4. 29.4. 29.4 is your h2. Then I'm going to measure h1. The distance is fixed 50. Starting from here 10, 20, 30, 40, 50. Around 60 I'm going to get. Your h2 is h1 is this. h1 is 23.6. 23.6. Then repeat this experiment for different length. Now previously we took the measurement here. Now you shift 10 here. This is your new h2. h1 10, 20, 30, 40, 50. Here this is new h1. And next shift another 10 centimeter and then you will get h1, h2. By using this formula you can get the theta, 3 theta values. Get the average of this. This is the average theta for this experiment. Part 2, the relation between displacement and time. You're going to get the relation between the displacement and time. To do this schedule we are going to fill. First, I'm going to fix the x1. x1 is the position of gate number 1. x2 is the position of gate number 2. This is already fixed. I'm going to measure the position of gate number 1. In order to fix the gate number position of gate number 1, we assume the initial speed equal to 0. How I'm going to fix the gate number 1 position? Let me take this. Take the glider. It should be touching this part. Right? It should be touching this part. Now, press this. See, the light is glowing. This light is glowing. And move this slightly to the right so that the light stops. Now the light stops. Now, check out this. The position of this is your x1. And take the ruler and measure this. Now this is the position. Now see the ruler is standing right here and you have to measure this distance. This is 14.5. 14.5 centimeter is your x1. Now we are going to fix the x2. x2 is 60. Starting from here 60 centimeter. 10, 20, 30, 40, 50, 60. I'm going to fix the gate number 2 at 60. Now fix this and fix this at 60 Now, say this is 60. Now I fix this gate at 60. The next step is you have to check the height of the gate is okay or not. See this. This hole, it should be crossing this. This is slightly, little bit high. Let us bring this slightly down. This is going. This hole should be touching, cut by this. This is working. The height is okay. The next step is we are going to fix the timer. Switch on the timer. Press time. I'm going to measure time today, right? And what mode I'm going to measure? 2-gate mode. 1 gate, fence, 2 gate. Now this instrument is ready for the measurement. This instrument is ready for the measurement. What I'm going to do now, and fix this, X1 is fixed, X2 is fixed. And keep the glider here, it should be touching the left, and then press the start button. Now the start button is pressed. There is a star you can see. Once everything is ready, just take your hand. Now it started moving. You can get the time taken to travel the distance. 1.1760. That is 1.1760. And this x2 minus x1 is 60 minus 14.5. You can write the value, right? And square of this is t square. The next, I'm going to change the distance x2. Previously I did it for x60, now 70. 70 from this, 10, 20, 30, 40, 50, 60, 70. Now you can move this, and first you have to check the height. It is too high. I have to bring down this lid. Now check the height. It is okay now. Now I'm going to fix your x2. x2 is 70 centimeters. Now it is 70 centimeters. Now I fixed your x2. Let's go here and press this button, the black button. Now everything is ready. Now release the glider now. Take my hand. Now this is traveling. Now you can get your time taken to travel the distance. 1.3222. 1.322. And this will repeat this experiment for different values of x2. 70, 80, 90 until 150. After completing this, we are going to square this. For example, 1.1760. I'm squaring this. Square this. How much I'm getting? 1.38. I'm writing in 2 decimal accuracy. Maintain 2 decimal accuracy throughout this. Right? The next, I'm going to draw the graph between x2 minus x1 versus t square. x2 minus x1 should go to y-axis, t square should be x-axis. T square, you can complete the data here, and this is x2 minus x1, and this is 60 minus 14.5 is equal to 45.5. This is 45.5. This is 70 minus 14.5. This is 55.5. This is 60, 65.5. 75.5. This keeps going. I'm going to draw the graph between x2 minus x1 versus t square. x2 minus x1 second square meter, centimeter. Centimeter is the unit. Here t square, second square is the unit. Then I'm going to start. What is the starting point for this? It is 45.5. The gap is 10, 10, 10, 10, 10. I can take delta y as 5. Now take this 60. The minimum value is 45.5.
دكتور
Take 45.5. This is 46.5. This is 55.5. Sorry. 50.5. This is 55.5. This is 60.5. It keeps going. And similarly, I can calculate the increment here. I am showing the data roughly. This is completed. This I did for example. Is 1.38 is the minimum value. 4.91 is the maximum value. How to get your delta x? Delta x is equal to the maximum value 4.91 minus 1.38. 4.91 minus 1.38 divided by 18 is the number of boxes in the x direction. 4.91 minus 1.38 divided by 18 is equal to 0.196. Let me take slightly bigger than this. Delta x slightly bigger than this. Can I take 0.20? 0.20 is my x increment. And I have to start with the minimum value. What's the minimum value here? 1.3. Here I can take 1.30. Add this with this. 1.50. Add with this. 1.70. 1.90. 2.10 and keep going. Right? Then you can plot all the points on the plot all the points. You have to take the ruler, adjust the point. The majority of the points should be touching. The ruler should touch the majority of the points. You can connect the points and get the line. Suppose few points not on the line, let us not worry about that. The majority of the points I have to take. Now the next step is calculating the slope. The slope y2 minus y1 by x2 minus x1. Select any two, pick up 2 points. This point I cannot select because it's not on the line. I can draw this. This is your x1 and this is your y1. And this is your x2. And this is your x2 minus x1, y2 minus y1, you can write the values here and you will get some number. The unit, centimeter is the y unit and second square is the x unit. I am going to convert this into 10 to the power minus 2 meter per second square. This is your slope. I am going to calculate your g value, g value from this x2 minus x1 of g sine theta t square. Now let me get this value g. G value is equal to 2 into x2 minus x1 divided by sine theta t square. I'm going to write this into 2 parts. 2 divided by sine theta into x2 minus x1 by this is the constant part, this is a variable part. The theta, I have the average only from the first part, and this one, x2 minus x1. How can I get this? The meaning of the slope. The value of the slope, meaning of the slope is x2 minus x1 by t square. x2 minus x1 by t square can be replaced by slope. Now, let us come to this. G equal to 2 by sine theta replaced by slope. The entire thing is replaced by slope. Now, using this formula, I can get theta. Theta is the first part. The value of theta you got from the first part. This is average value of theta. And substitute the value of slope. Here, you will get G. G meter per second square is the unit of the percentage of error. G experiment. How much value of G you got from your experiment right here? The accepted value of G is 9.81 divided by 9.81 into 100. Take the absolute value of your answer. That is the meaning of these two lines front and appeared in the front and back. And this gives you the percentage of error. The percentage of error should be less than 5%. Less than 5% value is accepted for this experiment. Uniformly. Shiva, any doubt?
The average theta, doctor, we sum them and
Yes.
we added them and divided them by 3.
Yes. Now,
Okay.
I will share you the data. You can copy the data on your paper and then I will tell you how to calculate it. Now you can copy the data on your paper.
Doctor,
Yes.
here the sine inverse equal to the theta, right?
Yes.
So we write them both
Yes, same.
numbers.
Yes.
Oh, okay.
Copied, Shiva? Done?
Yes.
Okay. You can copy the second data. You can copy this. The first column is already printed on your paper. Third column and the x1 you copy.
I send it in the group.
Okay, copy on your paper, then I will explain you how to draw the graph.
Doctor,
Yes.
yes, Doctor, in the previous page, the theta, should I write it in 2 decimal or?
Yes. You can write many decimal because I'm not going to draw the graph. Minimum 2 decimal.
Okay, thank you.
Only for the data I'm using to draw the graph, it should be 2 decimal. I'm not going to draw the graph by using theta. Once you finish copying, you tell me.
Doctor, I have to take the average theta for G. Am I right?
Yes, yes. Done? Shiva? Finish
Yes.
copying? Okay. I will tell you how to calculate and then draw the graph. Now here, the sine theta, the theta I want to calculate. The theta can be calculated by using sine inverse of h2 minus h1 by L. This is h2 minus h1 by L only. h2 is 30.4 and h1 is 24.5 divided by 50. Here, if I find the sine inverse of this value is equal to 6.7766. Theta I can write even 4 decimal accuracy. Because I'm not going to draw the graph using this, you can maintain minimum to maximum any decimal accuracy you can maintain for theta. Then repeat this calculation for the second row and third row also. Now how many thetas we have? 3 thetas. Sometimes all the 3 values are equal, sometimes different. To get the correct value, we are going to take the average of the 3 theta, 3 values. You know how to take the average? Add the 3 numbers divided by 3. And that final answer is the average theta. We are going to use this theta in the calculation of acceleration due to gravity g at the end. Come to this.
Doctor, I can take the for decimals after the
Yes,
point.
yes, you can keep because I'm going to use only for calculation.
Mm-hmm.
x1, x1 is 13 centimeter. And first I'm going to calculate this column. This column is x2 minus x1. For here, for first row, x2 is 60 minus x1 is 13. The answer is 47. For second row, x2 is different, but x1 is the same for entire experiment. 70 minus 13 is 57. Continue this until the end of the schedule. Right? Any doubt in this, Shubha? X2 minus x.
Clear.
Come to this theta, sorry, t. The t is given. I want to get the square of this. Can you square this? If you square, you will get 0.82 square. I'm getting 4724 for decimal. I'm going to use this data to draw the graph. The graph sheet,
4
I
decimals.
can show only 2 decimal accuracy, right? Only 2 decimal accuracy I can show. But I want to make these two numbers after the point. How can I make the last two numbers? Last number is 4 less than 5, just I can delete it. Now last number is 2 is less than 5, just delete. Now two numbers, maintain the 2 decimal accuracy for the last column. Yes, I'm going to use this data for drawing the graph.
Doctor, in the second one we have a 0.8281.
8281
Mhm.
and 1 delete, 8 delete, 1 add to the left one.
It will be 0.83. Mhm.
Yeah, whatever the things, you know how to do it. You studied this in the mathematics.
Okay.
Now square this and get. Now you got these values. You're going to draw the graph between x2 minus x1 versus t square. And this quantity I'm going to take along the y-axis. This quantity I'm going to take along the x-axis. Clear?
Yes.
Now I will explain you how to draw the graph. Not this. Yes.
Doctor,
Yes.
the slope equals G.
Wait. I did not finish. This is x. This is y. You know the bigger boxes in the x direction, and also you have in y direction. First, you should write the quantities. What you are going to take along the x-axis? Here, t square second square is the unit you are going to take along the x-axis. Along the y-axis, what quantity you are going to take here? x2 minus x1 centimeter is the unit I'm going to take here. And from this graph, please try to write this delta x. How much delta x I'm going to take here? 0.10.
Doctor, I have to take it, write it in the graph sheet. This
Yes.
text.
Whatever I'm writing, you should write on the graph sheet. Delta y is equal to 5.0. How I take this, delta x is equal to 4, sorry, delta x is equal to 0.1. Let me explain this. Delta x. And go to the x-axis in the schedule. What is the maximum value? 2.19 by 6. 2.19 minus 0.67 whole divided by 18. The number of boxes in the x direction. If you do this, how much you are getting? 2.19.67 divided by 18. How much you are getting? 0.0844444. I can convert this into decimal accuracy. This that get deleted. Now this is equal to 0.08. I can draw the graph with this number, but it is better to take a bigger than this. I'm going to decide to take bigger than this 0.10 because this is more easier to handle than this. Is it right? So I decided to take delta x is equal to 0.10. Do you understand why I put here 0.10? Let me go to delta y calculation. Delta y and go to the schedule and check the second column. The maximum number is 1.137 and 47. Here 137 minus 47, big number minus small number, divided by number of units in the y direction. If you count the number of units in the y direction, boxes in the y direction, some graph you will get 26, some graph 27, some graph 24. I just put 25 is equal to 3 point, how much you are getting? 137 minus 47
3.6.
divided by 25. 3.6. If I take the bigger one, I can take 4. But I'm not going to take 4. I am going to take delta y is equal to 5.0, because if you check the second column in the graph, sorry, in the schedule, the gap between two numbers is 10. The gap between two numbers is 10. If I take 4, and it is difficult for you, and if I take 5, it is easy. It's not very big difference, it's a small difference, right? Now, this is the reason why I decided to take delta y equal to 5. Now, let me write the numbers in the x direction. What is the minimum value in x direction? 0.67. Can I take 0.6? 0.6. Add this with the increment. Increment is 0.1. That means 0.7, 0.8, 0.9, 1.0, 1.1, 1.2, 1.3, 1.4, and so on. Continue until the end of the page. It's clear? Now
Yes.
go to the y-axis. What is the minimum value here? 47. Let us take 47 as it is. 47. Add this with the increment. Increment is 5. 47 plus 5,
52.
52. 52 plus 5, 57. 62, 67, and so on. 72, and so on. If I look at the graph, sorry, the schedule, you have 47, you have 57, 67. It is easy for you to plot the point. What is the first point? 47, 60. What is that? 60. Oh, not here. It is in the schedule. 67, right? 47, 67. 47 the y-axis, and follow this line. 67, but 67 is not here. 60 is there. 61, 62, 63, 64, 65, 66, 67. Can follow this line. And this is your point. Is it clear? This is your
Yes.
point. And come to this. This is 57. What is the next number? 0.91 square. You put 83.
0.83.
0.83. Let me put this one. 0.57, 83. What is 57? 57 is here. You can follow the bigger line. 83. This is 80. 1, 2, 3. You can follow this. This is the point. You can plot all the points available on the schedule. After plotting the point, take a ruler, adjust the position of the ruler so that the majority of the point touching the edge of the ruler. Now you can draw a line connecting the majority of the points. You know the majority is more than 50%. The majority of the points lies on the line. Now if this point is moved slightly away, no problem. Now I am going to calculate the slope. The slope calculation. The slope, how to get the slope? y2 minus y1 by x2 minus x1. How to get y1, y2, x1, x2? Take 2 points on the line. It is better first point and last point on the line, not on the graph. It is on the line. It is your x1. This is your y1. The last point on the line. Suppose if you have one point here, you should not take because it is not on the line. This is your x2.
Doctor, that must be on the line, the 2 points.
Yes, yes. And show the line like this. Draw a line and show your x1, x2 on the graph. Can you pick y2, y1, x1, x2 from the graph? And write the values here. You will get some number. Then the unit. What is the unit of y direction? Centimeter. Unit of x direction, it will be down. It is second square. Centimeter per second square. How to convert this into meter per second square? Just write the number and centimeter.
Multiply by 1000.
10 to the power of minus 2 meter per second square. Multiply with 10 to the power of minus 2. Now you got the slope in SI unit. How to get G? The G formula already you got, right? This is the formula to calculate your G. Can you pick the formula now? G equal to 2 divided by sine theta x2 minus x1 by t square. Now let us go to the graph. The meaning of the graph. The value of the graph x2 minus x1 by y2 minus y. The meaning of the graph. Sorry, meaning of the slope. Sorry. The slope is equal to y quantity by x quantity. What is y quantity? x2 minus x1 by x quantity is t square. Wherever you find x2 minus x1 by t square, you can replace that value by slope. Now come here. x2 minus x1 by t square, can I replace by the slope? Now G equal to 2 divided by sine theta. Theta is the average theta value from the schedule 1 into slope. Now finally you will get the answer. Meter per second square is the unit of G. Is it clear to you, Shiva?
Yes.
Yes, yes,
Okay.
doctor.
The next is the calculation of error.
دكتور
Yes.
Yes. Can you go up please?
Wait.
Okay.
The slope, error equal to G minus 9.81. G value, whatever the value of G you are getting, just write your answer in your experiment. Into 100. The 9.81 is accepted value. And this will give you the percentage of error. The error percentage for this experiment should be less than 5%. The accepted value of error percentage for this experiment is 5%. The error should be less than 5. And we will talk about the source of error, major and minor sources. Yes, what is your problem, Shiva?
Now, doctor, I am write the slope and G in the report, right?
Yes.
And the blue color in the sheet.
No need. No
No
need
need.
to write.
Okay,
Yes.
thank you.
Now I'm going to share you the sources of error, major and minor source of error. The major source of error introduced in the calculation of acceleration due to gravity in the measurement of the initial position x1. x1 we are measuring by tape measure. And the final position x2. x2 also we are measuring. Initial position x1 and final position x2 of the glider. The minor source of error introduced in the calculation of acceleration due to gravity is in the measurement of time taken t. Time taken to travel the distance x2 minus x1. The time taken here, you are measuring by using the timer, right? And that is coming under minor source of error. Coming to the conclusion, the acceleration due to gravity was found to be, write the value of G you are getting in your experiment. 10 meter per second square. The error introduced in the measurement of acceleration due to gravity in this experiment is, how much percentage of error you got? Just report the value. Any doubt, Shabab?
Doctor, why the x1 and x2 is the major source of error?
X1, X2, you are fixing, you are measuring it manually, right?
Yes, right.
Instead of taking a correct value, you may take 0.1 or 0.2 less or more.
Mm-hmm.
There is a more probability for introducing error there. One student will measure perfectly, other student will not do the same perfect measurement.
Uh-huh.
Any other doubt, Shabab?
Doctor,
Yes.
delta x and delta y, you want to write it in the sheet graph or not?
Yes, I want the delta x and delta y value on the graph
Without the
sheet.
calculations, right?
Yes, yes. Calculation
Okay.
is for you. I want this entire thing.
Okay.
Yeah, I will show you the graph. I'll draw the graph on the Excel sheet. This is the graph drawn on the Excel sheet. You can check for the values there.
All the points on the line.
Yes, for me it is on the line.
And doctor, can you go to the delta y? I want to see it. Doctor? Yes, okay. Down, please, doctor. Hmm. Doctor, can I divide it by 20, not that 25?
Yes, you can.
You can. If I that divide it by 25, I will get wait 20. I will get 4.5. Can I convert it
4.5,
to
fine.
can I convert it
Fine.
to 5?
Yes,
No problems.
yes, yes.
Okay, thank you. Doctor, I have a question for the midterm for
Yes.
the theory part. It will be
Mhm.
on a ninth week or
Yes, ninth week.
ninth week.
Yes.
It will be on the campus.
Yes, yes.
Doctor, also the calculus and chemistry.
Yes, check your college calendar for the date, for
Uh,
the type.
but the
Date.
doctor, the physics and calculus will be in the ninth week.
That's yeah. Look for the schedule. They will give the exam schedule. The date I don't
Doctor,
know. This
Okay,
it will be in the ninth week.
in the ninth week.
Yes,
The other subjects like English, Arabic will be in the eighth week.
I don't know. They will give you the schedule.
Uh,
The exam schedule will be given by the college.
but the physics and the general studies will be in the ninth week.
For all the dates, you look for the schedule given by the college. The exam, the midterm exam is according to the exam schedule given by the college.
Okay.
Okay, Doctor.
Yes.
Usually the weeks of midterm, you don't have culture, right?
Pardon? You don't have?
Usually week of the midterm,
Yes.
we don't have a lecture, right?
Yes. 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 Yes.
Okay, thank you, Doctor.
Okay.
the practical physics, we don't have midterm, right?
Yes. Yes. What is the final exam?
Okay.
Doctor, did you show us the source of error or not yet?
I showed some time back.
Oh, because I'm reconnecting, so maybe this time you show us. And the error percentage should be less than 2
5.
or 5.
Less than
Okay.
5. Yes.
Can we leave now, Doctor?
If no doubt, you can. This is the time for writing the drawing the graph and writing the report.
Because I have a class after that, so